Hello and welcome to another video. In this video, we're going to be doing the first problem from Biweekly Contest 123, and it's type of triangle 2. And in the problem, you're given a zero-indexed array nums of size 3, which can form the sides of a triangle. A triangle is equilateral if it has sides of equal length, isosceles if it has two sides of equal length, or scalene if all the sides are different. Return a string representing the type of triangle that can be formed, or none if it cannot be formed a triangle. So in this example, in this first thing, it's equilateral, and in the second one, it's scalene because all of the sides are different length. But notice that there's another thing for a triangle to have a triangle, and this is the one you have to check for. So for any two sides, the sum of two sides must be greater than the third side. So they kind of show you here. And the way we can handle all this really easily is by sorting this. So if we have three sides, like let's say we have this 3, 4, 5. Let's say they weren't in order. Like let's say it was like this. The easiest thing to do is to sort it, because if you sort and you get this, it's going to be really easy now for us to tell all these things. So let's kind of walk through our cases. So for the equilateral triangle, all you have to do is just check if the middle element equals the left and it equals the right. And if that's the case, then we have equilateral. So for two sides of equal length, we can just check, does this equal one of these or another one? So you see what I'm kind of getting at? So you can structure the code by just checking, is this middle thing equal to the left? Is it middle to the right? And add up how many things it's equal to. So if it's none, it's scalene. If it's 1, it's isosceles. And if it's 2, it's equilateral. And the last thing you have to check for is this third thing where every two sides added is bigger than the other side. And because we have it sorted, we can just check, are the two smallest sides added bigger than this side? And if that's the case, then everything else will obviously be bigger, right? So like if these two are bigger than this, then obviously like these two are going to be big. Like anything with the 5 is going to be bigger than this. So that's the only case you have to check for now. Are the smallest two sides bigger than the biggest side? And that's pretty much it. So sorting is going to help us a lot. So we can actually, I wrote this earlier, but we can actually even get rid of all of these. Or you could write it like this. I guess either one is fine. So basically you sort, and then you just check, are the two smallest elements bigger than the biggest element? If they're not, then you can't make a triangle, so you just return none. If the middle element is equal to the left and the right, then you return equilateral. And if any one of these is equal, right? If the middle element is equal to the left or the right, then you return isosceles. If nothing is equal, then you should return scalene. And you can have an integer for like how many things it's equal to, but this is also a fine way of writing it. But essentially, it's a kind of easy one, but yeah. And so if you run it, it's pretty good. I think everyone's going to have like the same O1 solution, so there's not too much to talk about in runtime because you only have three sides. So it's going to be time O1, space O1. Pretty easy one. And I actually did finish all the other problems, so I'm just going to make videos for those shortly as well. Probably I'll have them all up today. And yeah, thanks for watching, and I'll see you in the next one.